All right, so again, this is gonna be this is still our lesson 8-2. We need to finish. We never went over the ones with like a fractional exponent, so let's go over this one. But if you remember though, I kind of talked about it on Tuesday. I think it was Tuesday. So I had a side note. And then I told you guys like a x to the 1/3 is basically the same thing as a cube root of x. Whatever the denominator is, that's your index in your radical, okay? So likewise, if I have an x to the 1/2, that's going to equal the square root of x. So whatever's in the denominator is the index, but because that's a 2, that's a square. But we don't really put the 2 there, it's just implied to be there, okay? So we talked about that on Tuesday. So basically, you're going to rewrite this equation in radical form, okay? So you take whatever's inside the parenthesis, and you take the square root of that, okay? Because that whole thing is raised to the 1/2. That means that whole thing is under the square root. I have the square root of x squared plus 6x, okay? Minus, then you would do the same thing with this one. This whole thing is raised to the 1/2. So you take the square root of that whole thing, the square root of 2x plus 5 equals 0. Okay? All right, and then we haven't seen one like this where we have two radicals and they both have x's. So whenever this happens, you're going to want to move one of them over to the other side. That way you have a square root on both sides, so that when we square each side, both radicals cancel, okay? So on this one, I want to first move this one over to the other side. So add the square root of 2x plus 5 on each side. Because you want them to be isolated. So we do square root of x squared plus 6x equals positive square root of 2x plus 5. You want both of these to be isolated on both sides, so that when we square each side, both of them cancel simultaneously, okay? So like the square root would cancel the squared, and then I'm left with x squared plus 6x equals. Then the square root cancels the squared, and I'm left with 2x plus 5. We basically end up with whatever was left on the inside, okay? All right. And then I need to solve for x here, but I have a whole bunch of x's all over the place, and I have this x squared. So what did we do when we had an x squared somewhere? What did we have to end up doing when we had an x squared? Does anybody remember?
You put one side to 0?
Yes. Make one side equal to 0. Good. Because you want this to be in the quadratic form, standard form. You want this to be ax squared plus bx plus c equals 0. That's your goal, so that then you can factor. You do blank plus blank and blank times blank. And that'll give you your two binomials, okay? So I need to have the one side equal to the 0. You want this x squared to be positive. That means you want this to stay here. So you want these to move over to the left side, okay? So we're going to have to subtract 2x to both sides. But then I still have the 5 right there. So you also need to simultaneously subtract 5 as well. That way the 5's cancel there. We're going to get an x squared. And then what's 6 minus 2? 4. So I got a plus 4x and then a minus 5. Does that, that'll equal 0 on the other side, okay? Now I have it in standard form for my quadratic. I have an x squared, an x term, and my constant. So then we do what two numbers add up to the b value and multiply to a times c. So what do they have to add up to?
4 and 1.
4, well, and then multiply to a times c.
Oh, what?
So it'll be
Oh, never mind.
multiplied to negative 5.
So 5 and negative 1.
Yes. This is what they have to multiply. The only options for multiplying to negative 5 are like 1 and negative 5 or negative 1 and positive 5. So I know this has to be a 1 and a 5. But because the 4 is positive, I want the smaller one to be negative. Okay? So then I can factor this into two binomials. And then remember, we take this x squared, we split it in half. So 1x here, 1x here. So it would be an x and an x, because I'm splitting it in half. And then whatever you got for these two numbers right here, go in the second blank. So negative 1 and a plus 5. Okay, and then here's when you split them and make each one equal to 0 and solve for x. So like here, if I do x minus 1 equals 0, I would have to add 1 to each side. So that'll give me x equals positive 1. And this one, x plus 5 equals 0, we subtract 5 to each side. That gives us x equals negative 5. Those are the two possible solutions. So then I have to go check both of them, okay? We don't know if they're both extraneous. It could both be valid. It could be one's extraneous, the other one is valid. You don't know, so you have to go check both of them, okay? So check first, x equals 1. Well, it doesn't matter which one you check first, as long as you check both of them. But I would plug it into the one with the square roots, not the one with the fractions. So I'm going to go plug in the square root of, notice I have a x squared, a 6x, and a 2x. I have 3 different x's where I need to plug in. So I have a x squared, that's a 1, that's a 1 squared plus 6x, and so my x is 1, minus the square root of 2 times x, which is 1, plus 5. We're trying to see if that's going to equal 0. All right, so we're going to do the square root of what's 1 squared? And 6 times 1,
6,
and 6 plus 1,
7.
7. So you can do all that mentally. If you can do it mentally, do it mentally. If not, write it out. That's square root of 1 plus 6 gives you 7. Minus for the other one, what's 2 times 1? And 2 plus 5? 7. Notice I got square root of 7 minus the square root of 7. Those are going to cancel. It's going to be a 0. So did that equal 0? Yes. That means x equals 1 is valid. All right, but then we got to check the other one also. So check x equals negative 5 this time. Check x equals negative 5. So plug it into the original still. I have the square root of x squared. So that's a negative 5 squared plus 6 times negative 5 minus the square root of 2 times negative 5 plus 5. And does that equal 0? All right, so square root of what's negative 5 squared? 25. Thank you. And what's 6 times negative 5? Negative 30. And then that's the square root of what's 25 minus 30? Negative 5. Can I have a negative under the square root? I cannot have a negative here. This negative changes it to imaginary value, okay? Remember, square root of negative 1 equals an imaginary number. So that means that this is imaginary. And because it's imaginary, that means our solution is extraneous. We cannot have imaginary values. This is extraneous. That means your only answer is x equals 1. Okay. So again, just to recap, your fractions, the 1/2 just means the square root. And when you have 2 of these, you want to move one over to the other side so that when you square both sides, they end up canceling. And then you get a quadratic. You end up having to make this equal 0. Factor, solve for x, and then go check both of them. Okay? So I'm going to have you guys go ahead and try the next example. And then I'll show you guys the solution when you're finished. So go ahead and copy this. Next one, we have x squared plus 3x to the 1/2 power minus x plus 8 to the 1/2 power equals 0. So you guys go ahead and try this one on your own, and then I'll show you guys the solution. All right, so hopefully you were able to get to this part, x squared plus 2x minus 8. Then you had to figure out what two numbers add to 2 and multiply to negative 8. So what should those two numbers be?
Negative 4, 2.
Well, it should be a negative 2 and a positive 4, right? Negative 2 and a positive 4. So this ends up being x minus 2, x plus 4. So then when you solve for x, it switches, okay? When you solve for x, it should be a positive 2 and a negative 4. Shh, quiet, please. All right, so go plug in 2 in everywhere you have an x. So then this becomes square root of what's 2 squared? 4, and 4 plus what's 3 times 2? 6. And 4 plus 6 gives us 10 minus 2 plus 8 is 10. So root 10 minus root 10 is 0. So this one is actually valid. All right, then you have to plug in a negative 4 for the next one. So everywhere there's an x, you plug in negative 4. And then we get the square root of what's negative 4 times negative 4? 16. Negative 4 squared. Negative 4 times negative 4 is positive 16. And then 3 times negative 4 is negative 12. And And then what's 16 minus 12?
4.
4. And square root of 4 is 2. Minus the other one. Negative 4 plus 8, or 8 minus 4 gives you 4. So square root of 4 is also 2, so 2 minus 2 is 0. So that one is also valid. So for this one, they're both a solution. They both ended up being valid, so both of them would be your solution. Okay? All right, so that is the end of our 8-2 lesson. So you should be able to do now the full 8-2 homework. But if you were keeping up in class when I was giving you class time, you should only have to do number 6 and number 9. Okay? So I see some of you guys are still copying this down, but I'm gonna just write out on the corner right here. The rest of here is going to be like independent practice. So you guys are working on the 8-2. You guys have to just basically do numbers 6 and 9. Those are the last 2 examples we needed on your homework. And then I also want you guys to work on the 8-3.5. This one's a mixed practice. All right, so your 8-2 homework should basically already be done. You just need the 6 and the 9 to do. So rest of the period, you're working on 6-9 from 8-2. And then you guys are doing the mixed practice worksheet from the 3.5 the rest of the period. Okay?